There is a planet in our solar system where it rains diamonds. Not a figure of speech, not a poetic metaphor. Actual solid diamonds falling through the atmosphere by the millions, sinking deeper and deeper into a world we barely understand. Scientists first proposed this idea decades ago based on a few rough lab experiments, but most people filed it away under fascinating but unproven. Then JWST looked at Uranus, and what it found didn't just confirm the diamonds exist. It showed us exactly how they form and revealed something about this overlooked planet that changes everything we thought we knew. Uranus is the forgotten giant of our solar system. It doesn't get the dramatic red storms of Jupiter or the iconic rings of Saturn. It's just this pale, blue-green marble tilted sideways, silently orbiting the sun about 2 billion miles away. Most people couldn't tell you a single interesting fact about it. But scientists have suspected for decades that Uranus hides one of the most extreme environments anywhere in the solar system. Crushing pressures, bizarre magnetic fields, and somewhere deep inside, a layer where carbon squeezes out of the atmosphere and falls as actual diamonds. Today we're going to break down exactly what JWST found, why diamond rain is more real than you ever imagined, and what this reveals about how strange and violent the inside of a planet can actually be. The story starts in 1981 with a physicist named Marvin Ross. He was running calculations on what happens to methane, a gas that makes up a big chunk of Uranus's atmosphere under extreme pressure. Methane is made of carbon and hydrogen, a pretty simple molecule, but when you squeeze it hard enough, the carbon atoms break free from the hydrogen, and carbon under extreme pressure and heat does one very specific thing: it forms diamonds. Ross published his findings and suggested that deep inside the ice giants, Uranus and Neptune, this might actually be happening. That a layer exists where the pressure is so intense, around 1 million times what we experience at sea level on Earth, that diamonds are literally precipitating out of the atmosphere and sinking toward the core. For most of the next 40 years, this was an interesting theory. Nobody had a way to test it directly because the temperatures and pressures involved are beyond anything humans can easily replicate. But then, in 2017, researchers at Stanford did something remarkable. They used a laser to generate a shockwave, a burst of pressure so extreme it briefly replicated the conditions inside an ice giant, and they watched in real time as tiny diamonds formed, in nanoseconds, right there in the lab. That was the proof of concept. Diamond rain was real. The question was, how exactly does it work inside a planet like Uranus? And that is where JWST comes in. The James Webb Space Telescope was built to see things no telescope before it could. Its golden mirrors collect infrared light, the kind of light that carries heat signatures and chemical fingerprints. Things happening inside and around objects too faint or too distant for older instruments to detect. When JWST turned toward Uranus, it found something in the upper atmosphere that wasn't expected. Evidence of specific chemical compounds forming under pressure and temperature conditions in the cloud layers, a process that researchers say matches the early stages of what you'd expect to see if diamond formation was happening deeper in the planet. In other words, JWST gave us a window into the machinery, not just confirmation that diamonds exist somewhere inside Uranus, but actual evidence of the process beginning: carbon chemistry behaving in ways that could only lead to one outcome at greater depths. Think of it like watching clouds form before a storm. You're not inside the thunderhead, but you can see the conditions building, and you know exactly what's coming. Now here's what makes this really hard to wrap your head around. We're not talking about a few diamonds here and there. The estimates for planets like Uranus and Neptune suggest that thousands of tons of diamonds could be forming every single year inside these worlds. And once they form, gravity does what gravity always does: it pulls them down. These diamond crystals sink through the interior, growing larger as they descend through layers of increasing pressure. Some models suggest they may eventually reach a layer so hot and pressurized that even diamonds can't maintain solid form. They melt, and you'd have a liquid diamond ocean sitting around the core of the planet. A liquid diamond ocean, sloshing around under 20,000 kilometers of ice and gas. That's not science fiction. That's what our models say is sitting inside one of the 8 planets in our solar system right now. You might be wondering why Uranus and not Jupiter or Saturn. Those are bigger. Shouldn't they have even more pressure? The answer comes down to composition. Jupiter and Saturn are mostly hydrogen and helium, they're gas giants. Uranus and Neptune are a completely different category, ice giants. Their interiors are dominated by water, ammonia, and methane in exotic high-pressure states, and methane is the key ingredient. No methane-rich interior means no carbon to crystallize. No carbon to crystallize means no diamond rain. Uranus and Neptune are the diamond factories of the solar system, and JWST just helped us understand how the factory actually works. Here's the part that stops me cold every time I think about it. Uranus has been sitting there for 4.5 billion years, silently making diamonds. Right now, as you're listening to this, somewhere beneath that pale blue-green surface, carbon atoms are being squeezed out of existence as molecules and reborn as one of the hardest, most beautiful structures in nature, falling through a world we can barely see. We sent Voyager 2 past Uranus in 1986. One flyby, that was it. For 40 years, this planet was basically ignored, considered too far, too featureless, too boring to study. And the whole time it was hosting one of the most extraordinary ongoing processes in the solar system. JWST changed that, and scientists are now calling for a dedicated Uranus orbiter, a mission that would spend years in orbit around this planet, drilling down into its mysteries layer by layer. NASA has ranked it as the top priority for the next planetary science flagship mission. The diamonds brought us here, but what we find next might be even stranger. Uranus hid this from us for billions of years. A quiet, underestimated world, concealing one of the solar system's most violent and beautiful secrets in plain sight. And it took the most powerful space telescope ever built to finally start pulling that secret into the light. Diamond rain isn't just a cool fact. It's a reminder that even in our own backyard, 8 planets we've known about for centuries, there are processes happening right now that we are only just beginning to understand. So the next time someone tells you the solar system is boring, remind them about the planet 2 billion miles away where it rains diamonds, and where deep beneath the surface there may be an ocean made entirely of liquid gems. What other secrets is Uranus keeping?